So this work was primarily done by Quinn, who's either completing or already completed his PhD at the University of Canterbury with Andy Coben. And I'm looking forward to him joining my team in the near future on a longer-term basis. So the topic is actually a very mundane one in the sense that predictions and suggestions are actually commonly used in almost all keyboards, graphical keyboards today on smartphones and tablets. Also, as an industry trend, ranging from Google, Apple, Microsoft, we're all having very large-scale industrial effort in making user interface more proactive, more predictive, making more suggestions to the user, so the user doesn't have to do all the laborious manual work to get to their tasks and information. Just a few months ago, Google released auto reply to 1 billion Gmail users. So instead of writing a reply, often one of the pre-cooked 3 answers, short replies, could accomplish the task. Again, in the case of keyboard, again today, almost all smart keyboards have suggestions. The question is that how useful these suggestions are. At what point they will help the user rather than taking user's time. As we all know, any probabilistic inference cannot possibly have 100% accuracy. So it would probably benefit the user when the suggestions are correct, but distract the user or simply cost the user's time when the predictions or suggestions were not correct. So how do we quantify this trade-off? And surprisingly, this should be a very core HCI problem, but we haven't seen much of formal studies, investigations on this topic. In the AAC field, for accessibility reasons, this kind of thing was studied in the 90s or earlier. The suggestions were not very positive at the time. So to break down 2 steps, at least there's 3 aspects of suggestions that could be a cost rather than a benefit. One is that you need to switch your attention to attend to the suggestions away from the keyboard. The other is that you need to evaluate in case of multiple choices or even single choice, whether that's the correct suggestion you wanted. The third one is that if it is the correct suggestion, you want to take that suggestion, that takes another tab. So all of this, like if you tapped TH and you want to type THE, when you typed TH and THE was suggested, then there's no difference between taking the suggestion of THE or typing another letter E in terms of just the number of steps to take. So there's clear cases that the utility of a suggestion could be actually the same or lower than not taking a suggestion. So also there's a question like, how do you present suggestions? The system would always have something to suggest if the system is a smart system. There's a policy issue, so use anthropomorphic terms. You can think a suggestion system that is very, very active, like some of your frustrating friends and colleagues who would always say something, whether that was fitting to the situation or not. Or some other friends or colleagues who really have a lot to say, but they'll never say it. That's just also as frustrating. So it's introverted versus extroverted, or ambiverted in terms of the suggestions are gated by the utility. So only when the system thinks the utility is greater, if you take the option, the utility is greater than not taking it, it would present it or update the suggestion. So there's policy issues as well. So we decided to perform a formal study on this by experimentally measuring the utility as well as the various dependent variables in terms of performance and preferences. We use standard tasks of transcription tasks using McKenzie and Sukarov phrase set. We manipulated the experiment to 3 levels of assertiveness: extroverted, ambiverted, introverted. And also note that introverted means it will never make a suggestion. Therefore, it's a baseline or control condition. The apparatus is a little tricky because if you use an existing keyboard, the amount of prediction suggestions are highly context dependent. It also depends on how accurate you typed the letters. So we wanted to isolate those effects. So we used a keyboard, really is kind of a Wizard of Oz keyboard, where the errors were forced an error-free method. That is, you have to type the letters that is expected as this time. If you typed outside of the letter, the system wouldn't respond, so you have to type again. This introduces some sort of bias towards taking suggestions. Slightly more suggestions probably people would take than otherwise. But it isolates the error correction aspects of smart keyboards. We also manipulated suggestions to the degree that it matches the state-of-the-art current n-gram-based prediction accuracy in terms of word completion. We used about 46%. For the given test set, we know it's about 46%, which matches the state-of-the-art average. That is, in the best case scenario, if you take suggestions, you can save about 46% of your strokes. So what did we find? First, do people really take suggestions in this experiment? People clearly did. If you look at the right-hand side, for the introverted case, that is, the system never makes suggestions. The user has to type out all the letters. It's 1 taps per character by definition, so it's 1. But if you give them suggestions, we give a lot of suggestions, the extroverted version, you can see indeed people's average taps per character is 0.9 taps. So that means about 10% of the time, they saved about 10% of the keystrokes. And ambiverted is in between. If you look at the left-hand side, extroverted made a lot more suggestions than the extroverted, than the ambiverted version. People indeed also responded more and took more suggestions from those. So the theoretical value is up, but up. So they took more, but relatively speaking to the number of suggestions offered, they took percentage-wise took less. So, but the conclusion is that people did take suggestions. But interestingly, whenever they take a suggestion, time-wise, speed-wise, they actually take a hit. So this is 2 ways of measuring speed, either in WPM, which is more common, or use characters per second, which is more precise, because you remove the word length uncertainty, because WPM is assuming 5 characters per word. And you can see the more suggestions made, and the more people take suggestions, the slower they get on average. But however, if you look at their subjective ratings, this is using NASA TLX ratings system, both the physical demand as well as the effort judged by the users subjectively were much better when they were taking suggestions. So the extroverted version had a much significantly lower physical demand as well as effort. So in this case, the overall subjective preferences were different from at least time performance. So clearly this shows that suggestive UI still has a lot more research and a lot more progress to be made, and the understanding of them is certainly not very complete today. Purely from a time performance point of view, it's very hard to beat straightforward typing experience without taking any suggestions. even though suggestions are in all major products of keyboard today. But each time you take them, time-wise, it generally suggests it's not worthwhile. But in the future, if we have even better predictions, that the predictions potential is like more than, say, 80%, or longer span predictions, that is actually correct, then in that case, we may beat, the suggestion system may beat even in time dimension. But for the time being, as far as we can best match the state of art, it's not saving users time. But the results also suggest clearly people still prefer them in terms of their feeling about physical demand and effort. So the benefit clearly lies somewhere else, and often it's quite obvious and quite mundane. For example, they were not quite sure about the spelling. If it's suggested, they trust the system will suggest a correct spelling. So there's other benefits that are not so easy to quantify in this traditional HCI models. We find assertiveness and utility is one useful measure or method to analyze the benefit and cost trade-off. But clearly, as you've seen in Xiaojun's talk, as well as other talks, objective functions is what we are pretty good at, even though that still has limit too. But the subjective function of the user, or the happiness function of the user, is something that we still don't have a very good answer of, at least not formal answers in our field. So that's all.
Thank you. Any questions?
Yep. Hi, Anil Joshi from Bombay. So thanks for a nice experiment and a nice finding. In fact, interestingly, we have in our research also just been similar. So I had actually a couple of questions. One is about the error. You prevented users from making errors. So how do you speculate it would have been had you not done that? So which kind of is the more realistic situation? Is it likely to reproduce or reduce the time further or increase the time further?
That's a good question. So basically, we actually have many other papers published at this conference in previous years on a similar topic. So first of all, if you use the same decoding or language model power to correct errors as well as making predictions at the same time, there's an issue of how much you make that balance. And we have a paper with Xiaojun on this, we call it both correct and complete, that somewhat addressed that question. Also, in general, this experiment was designed in such a way to make suggestions more favorable. And despite that, we still find time-wise it's very hard to say. The design was actually isolating the error aspects away, so you don't make errors. Also, that means it's harder to manually type than otherwise. So therefore, overall, the experiment is biased towards showing suggestions time advantage. But despite that, we're still not showing a time advantage. That would be one conclusion.
So one other quick question was, if you actually had, so the quality of suggestions or the quality of completions, is it dependent on what was typed previously, or is it just the word completion?
This is a Wizard of Oz keyboard. It matches, it knows what user is going to type, so it's easier to do the manipulation.
So it was the best possible prediction.
But we match the degree of maximum keystroke savings, 46%. Okay. That's pretty much the state of art you can possibly do today. Tim.
Sure, it's really quick. I'm really glad you did the study. Very interesting. If you break down your results by when people actually chose the candidate, like whether it was after at the beginning of the word, and then also did you look at the length of the word and how that relates to people's perception of load and etc. Like it would be really interesting to see what your results would look like if you start breaking it down by those dimensions.
Yes. Honestly, I don't quite recall. And also, in full disclosure, this was a paper written 2 or 3 years ago. The paper was a lot more elaborate. We actually initially was more motivated by modeling. And that model actually breaks down this system using Gom's-ish kind of model or keystroke level modeling. But the reviewers didn't like it. So I lots of people felt like, why my papers all get accepted. This one was actually rejected a few years ago. So because the reviewers didn't like that very detailed analysis or modeling. So we dropped that and then it became a note. I don't quite recall whether empirically we actually dissected the data into those chunks. That would be an interesting exercise. I hope we still have the data somewhere.
Right, thank you very much.
Sure.